So we move on now to our next presentation, which will be given by Professor Paul Meyerhofer. He is professor for materials sciences at the Faculty of Mechanical Engineering. Again, we are in an interfaculty master program, which is offered by a high number of faculties here at TU Wien, and he will tell you all the details now.
Not all.
So the floor is yours.
Thank you very much, Peter, for the kind introduction. So I'm give you a short introduction to material science. I studied myself material science, if that works. No, it's dying. But it doesn't matter, right? So I studied myself material science in Leoben. And to give you a brief introduction on the difference between what you will have in TU Wien or in Leoben. And Leoben is more concentrated on metallurgy and how these materials are prepared by techniques very often used at Böhler first and so on. And here at TU Wien, you focus more on the details, on the structure, on quantum physics, and so on. Right. As I mentioned in the slide before, Austria is a materials country. So 30% of the gross product is basically has to do with materials. So I've tried to show you a few industry-related companies that deal with materials and where you would have a lot to do, to be honest. So when we look at the material science study program, which is at TU Wien since 2012, actually the same year when I entered TU Wien, but it has not to do with me. It was, of course, initiated before and just takes some time so that the program can run. It's an interfaculty program, and it focuses on engineering, but a lot of physics and chemistry of materials. And I also added in the introduction slide, so what we will learn is the staff of making good heroes for engineering heroes. And that involves, of course, a lot of physics, chemistry, mathematics as well, engineering, civil engineering, and so on. The language of most of the courses is German. A few ones are taught just in English, but we will try to move on so that everything will be taught in English. Basically, that's just the same slide as before, but I like this more because it arrows to material science, and the foundation of a lot of engineering is materials, and therefore material science. So when you have a bachelor program degree from the TU Wien, out of these red circles here, then you would be eligible for the study program material science without any additional courses. If you come from another bachelor, then there might be some equivalent courses needing to be taken, and we require the B2 level of German certificate. Materials and mankind, I'm sure you all know that many important periods in material mankind are named after the dominating materials. At least in my childhood, that was the cartoon number one. Does that anybody know from you still? Right? The Flintstones. And of course, as an Austrian, we should all have seen the Venus of Willendorf, which roughly dates to this period here. Right? And then, the Copper and Bronze Age, so where the dynasty of Egypt would fall in, as well as Ötzi, right? Then follows Iron Time, the Roman Empire. Maybe you have seen this movie, the 300. I also mentioned here that Europe for the Iron Time was extremely late, to be honest. So in Asia, it's roughly 1,000 years ahead of Europe in Iron Time, because there was a higher technology. Right, what is here? And the new new time, I would give it a name like Silicon Age. So it's not stones dominating our technology. It's not copper, not iron. It's basically silicon. Everybody of us has quite a lot of silicon in the pocket, in the cell phones, computers, and so on. There's no micro electronics without silicon. So therefore, I dare to name it Silicon Age. When we look at material science, and what you will learn in the material science program is that when we compare the building up of the materials starting from atoms and to components, it could be a car, it could be like this TM, then that covers a length scale of 10 to the power of 10. So the power of 10, so 1 angstrom to 10 to the power of 10 angstrom would be roughly here. And that is equivalent if you would compare a stone, which is roughly 1 decimeter, to our solar system, which is roughly 10 to the power of 10 decimeter. So that's just shall give you an overview on the length scale that is covered by material science. Right. That's, also, my group here doing some technical characterization of the quality of the surface to have wear resistance and so on. But why the stuff? Material science is so important. For example, the Physics Nobel Prize 2014 was handed over because of the right materials to emit various colors from LEDs, light-emitting diodes. So that's pure material science, basically. And to make a good product and to use sufficient production, of course, we need design and construction, but we need also the materials. So if you think on H2 technology and new energy and new environmental protective technologies, these all come with the materials. For example, this turbine here can run much more efficiently if you can increase the combustion temperature, right? But you are limited by the materials that can sustain 1,500 degrees C of combustion temperature. Or you can massively increase the efficiency by increasing the frequency or rotation speed. But that, again, comes with the result that you need to have lower weight. And lower weight, which would allow them for higher rotation, can then massively increase efficiency. Here's another, if you are not yet if you did not get your attention yet, this is an article published in 2015 that there was a study on how Chile or so different areas of labors are, right? And material scientists were leading the ranking, not by money that comes in, but by the balance between what you earn and how is the stress level. So the highest salary was at those days the pilots of drones, especially in military reasons. But I think that's also well known now. So that's actually a nice result, I would say. A little bit back to material science program. It is structured in these 5 different areas, the curriculum, and all of them would then have like core lectures as well as elective lectures. They are divided into these 5 different areas. And out of the given core lectures, you need to take 45 ECTS. And from the elective lectures, you need to take 36. But with the condition that at least one needs to be from another field. This one could be even 1 ECTS, but at least it needs to be from another field, so you can take 2, right? Or you can, of course, distribute the 36 to all of the 5 if you want to widen your expertise. Other than that, most of the master programs would have 9 ECTS for the transferable skills, so I don't need to discuss that more. And the master thesis is 30 ECTS plus the defense. Then, right, so for the situation that you would have a bachelor in technical chemistry, and there is a mandatory lecture in the study program of material science that you have already taken in your bachelor, but then of course you cannot do it twice, then there are some possibilities, and it's stated in the curriculum that if in the case you have already taken that, you need to take or select from a bunch of 3 or so. That holds also true if not the identical lecture was taken in the bachelor, but a lecture that has roughly 80% overlap with that what is required in the material science program. I think other than that. Then, right, I'll give you just a few examples here. The core courses could be applied quantum mechanics, material characterization, non-destructive testing, multi-scale material modeling. So there's also a lot of calculation and modeling activities in the program. Semiconductors, material science, and material science lab lectures, testing, and so on. And you would go deeper in understanding when you concentrate on interfaces, surface analytics, ceramics, composite materials, or sustainable development, and so on. When you graduate, that would be the scientific and technical skills that you would have gained, right? And there's a lot of abilities and industries I showed you before where you can actually place these gained experiences. Research and development at university or institutes, or other companies that need to do materials testing. I think there's a lot of industry in Austria where that is needed, right? Or you can be a technical consultant. Actually, many of my colleagues are consultants in Austria for this procedure. Right, and further academic path would be a PhD, and also in the field of material science, technical physics, or chemistry, or mechanical engineering. With that, thank you for your attention.
Thank you, Paul, for this nice presentation. What I forgot to say during your introduction, he is Dean of Academic Affairs for Mechanical Engineering and Material Sciences as well. Yeah?
That's right, yeah.
All right. Again, he will be available for questions whenever you have something to ask. You can just contact him. Yes.